It's a surprise.
Oh?
Yeah. Wow. I knew Google Maps had a lot of fans, but I didn't expect to see quite so many journalists here today. Something must be going on. Thank you so much for joining us. I'm Brian McClendon. I'm in charge of the Google Geo group here, and we are in charge of Google Maps, Earth, and all of the services that are possible with geodata today. I'm going to be talking about 3 underlying principles of Google Maps. Rebecca Moore is going to introduce some uses of Google Maps that are incredibly inspiring. We're going to demo some cool new features, and then finish up the talk. But first, I want to give you some history about where we came from and where I came from. I spent most of my career in Silicon Valley. 95% of that time was within a mile of the Googleplex. I worked at a company called Silicon Graphics for 8 of those years, building graphic supercomputers. These were very expensive machines. They were used to make the movies like Terminator 2 and Jurassic Park and The Abyss. They were also used in scientific visualization and flight simulators. This picture here is actually of the Infinite Reality. This was the most advanced machine at the time in 1996, and it had this powerful feature to zoom a texture from outer space all the way down to a narrow feature. But we wanted a demo that really demonstrated that. So we came up with this thing that we called Space to Face. And it may look familiar to you because it was a satellite image of the whole globe, very low resolution, with a satellite image of the Matterhorn, followed by aerial imagery of the Matterhorn, combined with terrain data. And this demo was so beautiful and was really the best thing we could show for infinite reality. It inspired a group of the engineers who worked on it. 2 years later, we decided to try to reproduce this functionality on a graphics consumer PC because things had advanced somewhat. We got a good version working, but it was on relatively expensive hardware. The challenges are that 3D graphics was just barely there in 1998. But it inspired us and made an aggressive prediction about what we thought would happen with 3D graphics. I'm relatively famous for aggressive predictions. I bought this license plate in 1998. I'm a technology optimist. I'm well known for saying things will happen, and I base my predictions on Moore's Law. I'm more often right than wrong based on random luck, but I'm still doing pretty well. However, the challenge with all predictions is timing. It was not until 2001 that Keyhole, the company, was funded as a new company. But 2001 was right after the dot-com bust. Most startups were just happy to be alive. We focused on a subscription service. We thought that travel and real estate would be a good verticals to go after. We operated on a shoestring budget, which really limited the amount of data we could provide. It wasn't until 2003 when a chance meeting with CNN got us into their mapping service providers and put us on air. It turned out that when Iraq was invaded in 2003 in April, things exploded. Basically, our service was on the screen 5 times an hour. Our server started getting very hot. We had to go to Fry's and buy disk drives and bring more machines in just to keep things alive. But this really grew the awareness and put us on the map, as it were. So in April of 2004, Sergey was in the board meeting discussing the IPO. Everyone has an IPO story. He was showing Google Keyhole to all the other board members, showing where they lived, and he was pretty excited about it. We were invited to come present a week later, and just 24 hours after the meeting, Google offered to buy us. And we, after some thought, accepted, because there's 2 things that Google could provide us that we couldn't get anywhere else, and that was scale and investment. When we'd been suffering, buying machines at Fry's just to keep the servers alive, right when we joined Google, they said, "What would you do with 1,000 machines?" Well, we figured out what we could do with that. We were able to set up on many different data centers and provide a much better service to a larger number of users. But the other thing was also really important. Larry looked at the proposal to buy this satellite data and said, why are you doing it just this way? Just buy it all. And this changed everything because this gave us worldwide coverage, many different countries, and made for a much better experience. And that led to the launch of Google Earth Free. However, even that was a challenge for Google. It turned out that in the first few weeks, we were over half the bandwidth served by Google. We almost took out Google Search before we got things under control. But the ability to reach so many users was something that only Google could give us. Meanwhile, sitting right next to us was a team building Google Maps. And I don't think people fully realized what the world was like. Back in 2004, web-based mapping involved waiting 10 seconds, not just for the first map, but any pan and zoom. You had to round trip to the server. You remember this. You had to type in different fields, 4, 5, and 6, address and street and city, what you're searching for, and some of the times it wouldn't work. So there was several different things new about this. This used Ajax, so the JavaScript running in the browser was able to make for a much more interactive experience. We pre-rendered the entire world tiles offline so that we could serve them very, very quickly, and this made the performance smooth and snappy. And the big thing was we added this single search box at the top. This was our geocoder, and unlike the ones in the past where we had to break things up, we made it a single box. Now, people were surprised and had to get used to this, so we gave them examples right here of the six different ways to use the service. So teaching was a big part of the process. But now I'd like to talk about how these apply to all of Google Maps. We've learned a lot in the last 7 years, and the focus we've had on comprehensiveness, accuracy, and usability are going to describe all of the work that we do on Google Maps. Google has always had an obsession with comprehensiveness. While they were crawling more and more of the web, we were trying to map more and more of the world. However, that first launch of Google Maps in 2005 actually looked like this. There's something wrong with this map. That's the United Kingdom, Western Europe, Asia, South America. We didn't have it. However, we wanted to launch early and often. And down here you see, this screenshot was actually sent in. It's in German because the Germans weren't happy with not being represented on the map. In 2006 and further, we were able to add more and more countries and complete the world, but we still had a skeleton. We were still missing, Eastern Europe and many countries around the world. But by 2008, we had a world map. We had licensed data from as many good providers as we could find, and we had good coverage, and this was the state of the world. But on the imagery side, things continued. So in 2006, after we had launched Google Earth, we had much of that imagery that Larry had bought from Digital Globe. But today, that same amount of data is launched every 2 weeks onto both Google Earth and Google Maps. In 2006, 37% of the world was covered with high-resolution imagery, and today, 75% of all people in the world can see their house in high resolution. Street View. It started in 2007. We launched with just 5 cities in the United States. We used 5-megapixel panorama cameras, and you may remember, it looked good, but it was a bit low resolution. We've been improving for years since then, and now, in 2012, we're in 39 countries. We have 3,000 cities covered, and we're taking 65-megapixel panorama, beautiful pictures. But we can't get the Street View car to every continent. Getting to Antarctica required me going on a boat, because I was going there anyway, and realized that this was a chance to add the final continent to Street View. So I was able to take these pictures in a wonderful trip that I had to the Antarctic Peninsula. So today we're also announcing that we've driven over 5 million unique miles in Street View. This is a huge achievement and shows just how much data can do to change the world. Combined with all of our imagery acquisition, Google now has over 20 petabytes of imagery. Street View is a big, ambitious project, but it inspired us to an even bigger one, building our own maps in a project called Ground Truth, or GT as we used it internally. We had been licensing data, but there were challenges with quality and freshness and the flexibility to offer all the services that we wanted to. Building our own maps gives us that freedom. We embarked on a 5-year mission to build our own maps from raw data. Combining aerial and satellite imagery, basic road data, and Street View allows us to make much more accurate maps than were previously possible. This is an example of the Atlas tool and shows how we can actually pull out, using computer vision, all of the street signs and automatically place them on the map and use the GPS tracks of the Street View cars to more accurately correct the road geometry. We're able to pull out turn restrictions and even down here speed limit signs. And this is all part of the process we use to make an incredibly complete and accurate map. And we're working this on many countries in the globe. However, in countries where there weren't good base maps and there wasn't Street View, we needed something. And we launched MapMaker in 2008. And for many countries, this is the best maps they have. So Pakistan is an excellent example of a country who's almost fully mapped from MapMaker. This is Faisalabad, and this is one of the best examples I've ever seen. Over a 4-year period, this went from a naked map to something that's more detailed than almost any American city that I know of. So you can see here you get labels in different languages. All of the plots are labeled. We have local business listings. We have parks, areas, bike paths. The people who are experts in their area are really able to add detail that isn't available elsewhere. And this is in Pakistan. Many other countries, the best maps are available through MapMaker. So, to wrap up comprehensiveness, in 2008, we had 22 countries, 13 million miles that were navigable or had driving directions. And it was all based on licensed data. Today, we have 187 countries. There's 26 million miles, so double, that are navigable. We also have 29 countries that have turn-by-turn voice-guided driving directions, all possible because of Google-sourced imagery and user-sourced imagery. And the coverage and quality continues to improve. We are certainly not done, but we're continuing to work on it. The next underlying principle is about accuracy. To align our imagery, we use many different computer vision and GIS techniques to match our various sources. Aligning imagery to terrain is actually one of the biggest culprit of errors. When you do orthorectification, you tend to get pretty big mistakes. But even after you iron all that out, there's still some cases where we have to correct beyond that and get small errors. Here's an example. A group of engineers came to me very recently after having found a set of misalignments that they couldn't explain through any of the other typical processes. It turns out that some of the imagery that we'd received hadn't accounted for one very important thing, plate tectonics. As it turns out, typically people map data in their own local data coordinate system because things move relative to each other, so most GIS is done locally. Google needed to map the whole world, and so we used algorithms to convert the different data coordinates around. But in many cases, it wasn't handled correctly at the source, or in some cases even with the algorithm, and we were able to detect that this road data here doesn't match with the imagery, and in this case, two different sources of imagery didn't line up, and it really mattered when the data was taken and how we corrected for the drift. So in California, it's 2.5 inches a year, but in the algorithm, it can be up to 15 to 30 years difference in data, so things do move around. This allowed us to knock out another source of error in our data, but there are many more that we continue to work on. Again, Street View allows us to help correct data. We use computer vision to pull out business names and all sorts of information directly from the picture. We combine this, again, with human operators to verify and validate when we're not sure. And this has added over 20 million precise geocodes to the Google Maps service. Users are a great source for corrections. We have a service called Report a Maps Issue that allows people to complain about anything that they don't see as right. In this example, a user has gotten driving directions, and they have an issue with this left turn. It says it should be restricted. And they report it to us, and using the tools similar to the ones I just showed you, we're able to look deeply into the data and use our Street View imagery in a very nice interactive method to compare it to what the user reported. In this case, it was very easy. Our Street View imagery actually confirmed exactly what the user was saying. We were able to verify and publish immediately. When we publish, all users who use Google Maps get those corrections within a few minutes. And this ability to quickly turn around corrections is very powerful and one of the advantages of having a holistic and complete database. In addition to all of the developed world, MapMaker has also been launched in developed countries like the US, Canada, and France. The ability to add your local knowledge enables users to add hiking trails, bike paths, and correct and improve local business listings. Today, we've launched MapMaker in 2 new countries, South Africa and Egypt. And later this month, we're going to launch in 10 countries, about 8 in Europe and Australia and New Zealand. The third element of a Google Map is usability. Being able to provide the power of the data to all users is critical, and we do it in many different services. This single search box is available on GMM, on web search, and provides much more than just a geocoder these days. Behind it hides the local business index, driving directions, the ability to turn on traffic, supporting many languages at the same time, and also the powerful suggest features. So I want to talk, here's some examples. Being able to do searches in any language, about any country, being smart about answering the question about Paris. Where is it? If you're looking at the whole world, it's probably in France. If you're in Las Vegas, it's actually the hotel. But if you're in Texas, you might actually find Paris, Texas. knowing context and providing the best answer to the query, saving the user time, is all part of the issue. But I want to bring up one example here in particular. Yesterday I was listening to NPR, and there was a story about finding jobs after college graduation. And this woman who had been a liberal arts major, liked being an RA, wanted to was a camp counselor, and thought that these experiences were really good. So she thought boutique hotels would be a good place to go search. So what did she do? She actually went to Google Maps, searched for boutique hotels SF, and was able to find a list of 13 boutique hotels, send her resume in, and within 24 hours, she'd gotten a job. Now, I can't promise that, but it's much more than finding your path home, finding a local business. You might be able to change your life. Traffic is another example where integrating it deeply within Google and the search service is very important. As I was being driven in Washington, D.C., and we had just passed a fender bender. And there's only a few cars backed up as we slipped by. Happened just less than a minute ago. And I looked at Google Maps, and it was green right then because it was so soon. Within 3 minutes, it had gone red. The ability to take sensor data and send it through the server and back down to users in only 3 minutes is an incredible example of the Google infrastructure and the ability to very quickly compute and return data back to users and help with navigation. Indoor traffic. So we have thousands of data feeds, and one of them is the floor plans for buildings that we've created. And it's not just about a picture on a map. The ability to have all the floors of a building, the ability to say, with my location, say what floor am I on and where am I in the building is very powerful. But that's also not enough. We launched indoor walking directions, the ability to carry you from outer space, or carry you from out in the world into the building, possibly to a transit station, to take a train and then back out. Navigating those complicated Tokyo subway stations, I think, is really only possible with Google Maps for mobile. So remember when I said that one of our innovations was to pre-render all of our map tiles in 2005? Well, a few years ago, we reversed that decision. Google's infrastructure had improved, and also networks had improved, and we were able to render tiles on demand within 10 milliseconds. That's 1,000 times faster than the experience in 2004. And this enables many new capabilities in Google Maps. And one of them is maps in your language. Now, this is a map of the United States, and it works fine if you speak English and can read it very easily. But if you read Japanese, you'd like something like this. And so the challenge of being able to provide all of the world's maps in your language is one of our goals. And we've done this for several languages so far, and now we're limited more by translation than by technology. But there are several other features. The Google Maps API is used by over 800,000 developers, and it's a service that's continuing to grow year over year. This is an example of the render-on-demand tiles. The ability for Google Maps API site to have its own look and feel based on what it asks for, I think is really important. And it's one of the strong appeals of Google Maps. Combining that with the power of the search box and all of the other infrastructure Google has behind it make Google Maps API an extremely popular service. But now, I'd like to talk about some other uses of Google Maps and Google Earth. Rebecca Moore is the head of Google Earth Outreach, and she has done some incredible work bringing social and environmental awareness and tools to those folks. So with that, Rebecca.
Thank you very much, Brian, and good morning, everyone. Yes, I'm head of Google Earth Outreach. So what happens when you take this breathtakingly detailed and vivid replica of the planet and you put it in the hands of the world? People do amazing things. So I'd like to share with you this morning how our partners, thousands of nonprofit organizations around the world, are using Google Earth and Google Maps to better understand the world, to raise awareness, and even to create solutions to some of the most challenging issues we face in areas as diverse as climate change, environment, human rights, cultural preservation, and humanitarian relief. So my first week on the job as an engineer on the Google Earth team, Hurricane Katrina hit. As you did just learn from Brian, Google Earth had just been released 2 months earlier. The US government asked for our help. So we worked around the clock every day, publishing near real-time imagery of the flooding. And I'm actually going to show you that now. We're starting on August 16th, before Katrina hit, but pay attention, we're about to switch to August 30th. You can see in the imagery where levees had burst, where the flooding was, which areas were still safe. As people over those days called 911 from the roofs of their homes, the rescue workers used this imagery and Google Earth to enter their address, figure out how to safely conduct a rescue, get the latitude and longitude from Google Earth, and call that information and those instructions to rescue helicopters. The Air Force told us later that using Google Earth, they saved the lives of more than 4,000 people. So that was when many of us realized for the first time that Google Earth was much more than just a fun way to fly to your home and figure out where to go on vacation. It actually was a uniquely powerful and meaningful and significant tool for public benefit. So from that, Google Earth Outreach was born, which is our initiative to help people around the world use Google Earth and maps to make the world a better place. So since then, there have been many, many success stories from our partners. And you can see some of them featured on our Google Earth Outreach site. We've received a lot of interest from people and organizations who not only want to use our maps, but they actually want to put themselves and their stories on our map, which is the world's map. So for example, take Chief Almir. He's the indigenous leader of a tribe in the Brazilian Amazon. In 2007, he was the first member of his tribe to go to university, and in an internet cafe, he stumbled on Google Earth. Like most of you, the first thing he did when he tried Google Earth was he flew to his home, which you can see his territory is surrounded by that red boundary. He was shocked because he couldn't appreciate from the ground what you can see from the air, that their primary beautiful rainforest territory is completely surrounded by apocalyptic devastation. And even in our satellite imagery, you can see the areas where illegal loggers were making incursions onto their land, some of which he had not even known about. So he came and he asked for our help to put his people literally on the map to help defend their territory. He said the time had come to put down the bow and arrow and pick up the laptop. So we did that. In 2008, we literally took laptops to the Amazon to help them go from the Stone Age. Their first contact was 1969, from the Stone Age to the Internet age. We gave them workshops on how to take photographs, videos, have the young people interview the elders, and put that information on Google Earth. There are now layers that they've created that help the Surowi and the world visualize the sites of illegal logging, where they hunt, where they fish, where they gather medicinal plants, their first contact with the outside world. This is an example. This is just a snippet of what's coming very soon from them. This is an icon that marks a historic battle. You know, what we've learned through this is that just as language is an expression of culture, maps are an expression of culture. We put the site of Gettysburg on our map. Now the Surowi are putting their battles and their stories on their map. It takes the concept of preserving their land and their culture and makes it much more tangible to people around the world. Chief Almir actually told us that in their language, Tupi-Monde, the Surowi people call Google Ragog Makan, which means messenger. Think about that. So today I'm excited to also finally announce that one of our newest partners, the Halo Trust, is today announcing and unveiling their work using Google Earth to illustrate and advocate for their cause. The Halo Trust is a nonprofit organization dedicated to eradicating landmines across the globe, and they've launched this project called Explore a Minefield. The group is using Google Earth to track landmine clearance operations, demarcating areas that are too dangerous to walk, identifying landmines for removal, and then marking the areas that have become safe to return. You can see in the green the areas they've cleared, and the red are areas still to be cleared. To give you an idea of the before and after, in Google Earth in 2002, you can see the area of Kunje in Angola had these minefields. But by the time of 2011, they had successfully cleared those mines, and these areas were now safe to return. So why is this so significant? Just for that one region I showed you in Afghanistan, once Halo had cleared the mines, more than 70,000 displaced people could return to their homes. Children could walk safely to school. The locals were again planting wheat, vegetables, and grapes. This is a snippet of their Google Earth tour they just launched today, and you can read about it in a lat-long blog post. This is an area along the border between Cambodia and Thailand. More than 2 million mines are located in this area that they are working on removing. Innocent lives are being put in peril by these enemies, essentially, that could strike at any time. Halo's goal is by taking abstract information and putting it on the map and making it more vivid, they'll raise global awareness and support for this humanitarian cause. So, as I hope you can see, something as simple as a map can be a uniquely powerful and meaningful way to bring to life these stories and these causes. People and organizations are changing the world simply through the ability to access and contribute to this map. We found that it can unite peoples and nations toward a common good. Thank you very much. Brian.
Thank you very much, Rebecca. Rebecca's Earth Outreach team inspired us at Google to continue to improve the capabilities of Google Maps and improve its impact on society. In May, we're moving incredibly quickly, and we're launching a large list of features shown here, and Google Geo team is moving at an incredible rate. And that's where we are. But it's still early days, and we're excited about the progress. And now I want to talk about 3 new demos that we're going to share with you. And first, Rita Chen, a product manager on Google Maps for Mobile, will present a new feature of Google Maps. Thank you. Rita?
Thanks, Brian. Good morning, everyone. Since we launched Google Maps for Mobile back in 2005, there has always been one key requirement to interacting with our maps: an internet connection. And because of this, people would often still carry around paper maps just in case. For instance, when traveling internationally without a data plan, or when traveling underground in the subway. Well, today I'm here to tell you that you will no longer need those paper maps. Like many other Google apps, Google Maps is going offline. This has been one of the most requested features and is coming soon to Google Maps for Android. We think offline maps really brings your mobile maps experience full circle by providing you with familiar Google Maps always in your pocket, whether or not you have an internet connection. So let me show you how this works. Could we please switch to the projector? Great. So let's say you find yourself traveling to London this summer, and you'd like to make sure you have a map available as soon as you land. Well, before you head off, simply find the area that you plan to visit on Google Maps and select Make Available Offline from the menu. You'll notice that we're estimating the amount of size that this map will take. So you can get a rough estimate of how much space this will take on your device and plan for any data charges if you're on a metered or capped wireless plan. Once you confirm your selection, the map will automatically start downloading onto the device. While it's downloading, let me share with you the biggest benefits of offline maps. If you have GPS enabled on this device, the blue dot will still work. It's like a digital "you are here" marker that follows you as you move. And if you have a compass on this device, you will be able to orient yourself without 3G or Wi-Fi, making the experience truly better than paper. So it looks like London is just about downloaded onto my device. So let me show you quickly what the experience will be like when you're offline. And to do that, I have another tablet here where I have not saved London. And I'll simulate being offline by putting both tablets into airplane mode. So let's start with the tablet that does not have the map saved. This would be your experience today if you were using mobile maps. And as you can see, the map may be clear at this zoom level. But as I get off the plane and start zooming in, you'll notice that the map is virtually unusable because the streets are not clear at this level. Now, as a comparison, the device where we have just downloaded the Google map, and you can verify that we are in airplane mode, as I start zooming in, the map remains clear, even down to street level. So you can easily see where you are and where you're going. Could we please switch back to slides? The ability to provide offline maps is just another benefit of building our own global base map. So next time, whether you're traveling internationally or underground, we hope offline maps will help you get around. Look for offline maps coming soon to Google Maps for Android. Now that we've shared that bit of news, it's my pleasure to introduce Luke Vincent, Engineering Director for Street View.
Thank you, Rita. And good morning. So as Brian's explained, Google Maps integrates many layers of information, and one of them is Street View. And I'm here to tell you about the next evolution in Street View technology. Before this, I should tell you a bit of history. So when I joined Google, what is now known as Street View was my 20% project. And I'm very pleased to have taken it so far. But in truth, it was not even my idea. The idea for Street View came from Larry Page, our CEO himself, who, before I even joined Google, had taken a camcorder and driven around the Bay Area, in fact, around Stanford for a few hours, taken some video from his car, and given the material to a computer science professor, along with some research funding, to bootstrap research in this area. He believed strongly that there was good information at street level that could be made useful to our users at scale and in the right interface. So to make this happen, in the early days of the project, we built a few vans like this. You can see it's a bit of a monster. It's got hundreds of pounds of equipment, many cameras, lasers, computer rack in the back, batteries, GPS, what have you. So with these vans, we're able to drive enough to capture a few cities, and we used the imagery to launch Street View about 5 years ago in 2007. However, those vans were not very reliable. Too many things could break at any given time. So over the next few years, we've been working to improve our technology, to improve the reliability of the cameras, the resolution. And after a few iterations, this is what the cars look like today, more or less. You notice on the top they have this 15-lens soccer ball-looking camera that is panoramic, gives you on the order of 65 megapixel resolution. These have been very reliable. And we've deployed those and other cars, other models around the world. And as Brian said, we have captured 5 million miles of road and made available to our users. However, you cannot go everywhere with cars. And we soon realized that in order to capture some of the world's most beautiful sights, we had to, in fact, do something different. So we built those trikes, where essentially we took all the equipment in the car, managed to shrink it and fit it onto a beefy tricycle. And we've taken those to a number of amazing and unique places in the world, like university campuses, like World Heritage sites, like amusement parks, and what have you. We even got creative on occasions, and we put those on boats, like you see on the left here, the trike on a boat on the Amazon River. Recently, we also put this tricycle on a train in the Swiss Alps and captured here a train track that happens to be a World Heritage site. We went a step further in 2010 when we decided to put the equipment on snowmobile and captured in this case, the Vancouver Olympic sites. We had a number of issues with vibration and with cold temperatures that caused the equipment to be unreliable. We over time solved them. And we were able to actually take this snowmobile to a number of ski resorts and gorgeous places again around the world. So this is again our quest to be comprehensive. But even more recently, we got involved in the Google Art project, where this time we wanted to give our users the ability to navigate museums virtually. And to do this, we shrunk the equipment even further and were able to put it on what we call the trolley, which you see here on the left. It's essentially like a little push cart with a battery, a computer, a little screen, the same camera, and you can wheel this around museums or large indoor spaces. And we've taken this to on the order of 50 museums worldwide, and of course growing. And this has been instrumental in launching the Google Art project recently, which was the second generation. So you ask, what next? Well, let me show you what's next. I will put down my, here's what we call the tracker. Let's see if I can put it on correctly. Here we go. So let me run the video. So obviously, lots of places, lots of gorgeous places in the world you can only walk to, right? So to do this, we developed the tracker. We were able to shrink the equipment even further, integrate everything together into one sort of portable package. This is on the order of under 40 pounds. It includes 2 lithium-ion batteries that can power you for the whole day. It's got a mini computer. It is Android-powered. Here's an Android phone that powers it. So this thing can sort of go all day. We intend to take it to a number of sort of national parks, to the Grand Canyon, to steps and beautiful places like castles and ruins. I really am interested in taking it to Venice, where you might imagine taking it to gondolas as well as on the narrow alleys all over the place. So it's really our next evolution. We want this to be able to take imagery in places where you've only dreamed of visiting. I even took this recently skiing. This was at Squaw Valley, just to test the equipment, see how it felt skiing, and it's really not so bad. You got to be a bit careful, obviously, but it works. And so when I was there, a kid came up to me and said, "Hey, why don't you use a GoPro camera instead?" So I said, well, after skiing for a few hours with this, there was some appeal to having a small helmet-mounted camera. But obviously with this, you can get far greater resolution, far greater quality. And we hope to use this and working with partners as early as this fall or maybe even sooner, go to a whole bunch of places and bring you imagery that you've only dreamed of seeing before. So with this, I would like to turn it over to Peter Birch for our final announcement of the day. Thank you. Here you go, Peter.
Thanks, Luc. So we've talked today a lot about what it takes to build a map that is comprehensive, accurate, and useful. But now what I want to do is talk a little bit about the work that we've been doing on the Google Earth team to bring the next dimension of maps, which is 3D. And so I'm going to give an overview of what we've been doing and a peek into the future. So it seems to be a lot of history lessons today, so I thought I would do the same. Earlier, Brian showed this shot of Keyhole. So this is the technology that was acquired by Google and has found its way into all of our mapping products, including Google Earth and Google Maps. And here, the 3D that we have is terrain data. And this works really great when you're trying to model the Matterhorn because it's really large. It's a great way to represent natural features. But when it comes to a cityscape, you get these buildings that are kind of flattened down on top of the terrain, and it really looks surreal and doesn't really give you any sense at all of what this place is like. By 2005, we started to introduce our first 3D buildings, and here we basically took the footprints of buildings and extruded them up to the height of the building. And so, for example, here in New York City, you can start to get a sense of the grandness of the buildings in New York City here, but by no means does this actually make you feel like you're there. In 2006, we introduced our first photorealistic 3D models. So here we're actually taking actual images and texturing onto the side of models. And this does a great job for showing detail of select landmark buildings. So here, for example, is San Francisco City Hall. Off in the distance there is Transamerica Building. Yeah, and just kind of not much else in between. So you have this sort of desolate landscape that really just leaves you wanting more. By 2008, we really ramped up our ability to get more 3D models in here. So here, for example, is a shot of San Francisco where we have lots of different buildings. So in urban areas like this, in urban cores in San Francisco, New York, and other places, we're able to get a pretty good coverage to the point where we now have millions of models in dozens of countries around the world. But there are some issues here. For one, the imagery that's here is coming from multiple sources. It could be aerial imagery, it could be coming from a user model. In some cases, it might even be a synthetic texture that doesn't represent the actual image at all. And so it creates some inconsistency that just doesn't look right. Also, not every model is actually, or every building is modeled. And the gaps also kind of break that illusion. Finally, you can see that we still have 3D buildings. Like you can see Coit Tower, the view of it is still laid down on top of the terrain, even though we have the 3D model next to it. So we knew we wanted to do something better. And we wanted to do something that would be comprehensive, something that would be consistent, and something that we could do at scale that would allow us to work towards our goal of modeling the world in 3D. So how are we going to go about doing this? So what we're doing is we're using automated technology to extract 3D from aerial images. Now, this isn't a new idea. This is something we've actually been working on for a number of years. But the quality just wasn't really there to meet the standards for Google Earth. That is until now. So let me describe how this works. So this starts with planes. And these planes are equipped with custom Google-designed camera systems where they're actually gathering what we call oblique imagery, where we're taking these 45-degree angle shots from each of the cardinal directions and directly down so that we can get each side of structures in an area to make sure that we have what we need to actually create an accurate model. Then the planes are flown in a very tightly controlled pattern to make sure that there's a sufficient amount of overlap so that we can get a complete picture and be able to represent large metropolitan areas. So then what we do is we use a technique that's called stereophotogrammetry to extract the 3D model from the multitude of images that we've collected. So here you can see again is San Francisco City Hall. And this is actually reconstructed from just the images that we've taken of these various different angles. And I mean, it almost looks like an old clay model, but in this case, this clay model has been sculpted by technology rather than by hands. So the next step is we actually, for each point or pixel on the model, we have to find the best possible color or image to match that point. And we go through the collection and this multitude of images we have to find the best one for each location. And we generate what's called a textured 3D mesh. And this is basically the building block that is necessary for a 3D graphics system to be able to render a 3D scene like this. So it's great if we have this really beautiful, detailed model. We're still not done because we need to be able to produce this and serve it in a way that can reach all of our users wherever they are in the world. And so to do that, we have to package up that information in a way that is efficient to store and serve, transmit over networks anywhere in the world to whatever devices our users are using to look at this data. So, you know, all this theory is great, but there's nothing like seeing it in a real product. So I'd like to show you that now. So if we could switch to the tablet, please. So here we are again. We can see that we're at San Francisco's City Hall. And this is a beautiful view. I mean, it looks like I'm just hovering above it taking a photograph. But what I'm actually able to do here is interact with this just by twisting my fingers. And you can see not only is City Hall a beautiful model, but everything around it is modeled as well, including all the surrounding buildings and even the trees and landscaping. And the consistency of this really does create that illusion that you're flying over the city. So let's do that now. So let's take our little flight here along Market Street. Again, you'll notice that every single building here is completely modeled. And that's important because we're trying to create magic here. We're trying to create that illusion that you're just flying over the city. Almost as if you're in your own personal helicopter. So here we are heading towards downtown. And let's just spin around and down to the ferry building. So Google Earth is a fantastic tool for people to be able to explore the world. But one of the challenges we've had is it's been difficult for people to be able to go in and explore the world in 3D and to discover new things. So what I want to show you now is an example of a new UI that we have that we call the tour guide, which is really a way for people to search and explore areas of interest that they might want to find. So for example, here we're back in San Francisco. And I'm just going to swipe this over to the side, and you'll see that there's a list of areas of interest that I might want to go explore. So maybe you're a Giants fan, so let's go check out AT&T Park. Just one more second. This is a technology demonstration, so all right, here we go. So again, if I want to come in and check out AT&T Park, we'll take a flight, and now we'll actually do a circle around the location. Again, here, giving you a great sense of what this location is like. And then to finish, let's just fly along the Embarcadero here. And here we are back at Kuwait Tower, but you'll notice that now everything in the landscape is modeled in 3D, really giving you that sense that you're there. Can we switch back to slides, please? So as you can see, this is just a sneak peek of some of the technology that we have available. But I'm proud to say that in the coming weeks, we're going to bring this new 3D imagery and the first of our metro areas modeled in 3D to both Android and iOS devices. And given that we really want to make sure that we model, the whole world to the point where everyone can be able to see their own communities, we're going to be bringing, we expect by the end of the year that we'll have communities of over 300 million people modeled in this new technology. Thanks very much. Back to you, Brian.
Thank you very much, Peter. So the obvious question is, when will all of this 3D imagery be available on the rest of the Google Maps services? And I think this example actually points out one of the challenges is that different devices have different issues. The ability to carry the power of 3D to JavaScript or to the variety of 3D graphics drivers that you might run into is one of the challenges that Keyhole and Google Earth and any 3D developed app faces over time. So our goal is to get it everywhere, and it's just a matter of developing the process carefully. So we've been able to bring Google Maps services to a lot of people. Today we're announcing that we're over 1 billion monthly active users for all of Google Maps services. And this is a very big number for us. What it means is that as we've been trying to create a map of the world, we've created a map for the world. As I've said, I'm a technology optimist. But amazing 3D graphics supercomputers going from the domain of Hollywood studios to anyone with an internet connection and being available in my pocket is something that, even beyond my most optimistic predictions. And I'm so happy to see that it's happening. I've been working in 3D and mapping technology most of my life. As an industry, we've made more progress more quickly than I imagined possible. And we expect innovation to speed up, and even more over the next few years. While we never will create the perfect map, we're going to get much, much closer than we are today. With that, I'd like to say thank you, and we're ready for Q&A. So I guess we want to announce that if